Welcome, everybody, to this edition of the Bell and Gossett podcast. I'm here and joined with Jennifer Freres. She's the American Product Line Manager for Motors at Xylem. I'm really excited. She's got some great experience, has been in the industry for more than 20 years. And today, we're going to talk about ECM motors. So I'm really excited about this one. It seems to be a hot topic that's coming up, getting a little bit more in the industry. Seems like it's kind of hitting in a different areas in the HVAC realm. So let's talk about some ECM motors today and over pumps. So Jennifer, welcome.
Thank you. Thanks for inviting me today, Kyle.
Absolutely. So let's jump into this a little bit. And why don't you tell me a little bit about your role at Xylem and the current focus on ECM motors?
Absolutely. So my role is really to understand the needs of the Bell and Gossett pump portfolio and what our customers are looking for as far as the motor portfolio. So I'm bringing in different motor technologies into the marketplace, making sure that I'm presenting the right motor portfolio to our end customers and really what they're looking for. And like you said, a lot of the new requirements and some new, it's not even new technology, is really in this ECM permanent magnet motor, which we're here to talk about today. So we will
that's
focus
awesome.
on that.
Yeah, I'm really excited about that too. So let's do this. Let's dive right into some of the ECM. I'm hearing a bunch of terms when it comes to ECM motors, and I'd love to call myself an expert, but there's a reason why I'm having you on the show here, obviously. So, can we talk a little bit about maybe what's a typical range that we see out there for an ECM motor? Is there a high end cap, or is there a sweet spot for some of these ECM motors?
There is a sweet spot. The smaller the motor, the more efficient you're going to get with being able to spin the impeller and how much energy you're using. So in the ECM permanent magnet motor range, really that sweet spot is going to be around, let's say, 5 horsepower up to 20 horsepower. So the offering does extend that range, but that's really where a lot of the industry is using these motors.
So that's probably a reason why we see some products out there really saying, here's the upper end of, call it 10 or 20 horsepower. It sounds like there are ECM motors that go higher than that, but the sweet spot, and they're more efficient at that lower end and lower range.
Correct. Yes. That's why it looks like a smaller offering. Yes.
Aha. Okay. So does that mean that, just thinking out loud, if I wanted an ECM motor, talking about some of these customers and a lot of these buildings going more green and more efficient, let's say if I wanted a 60 horsepower ECM motor, could I still get one?
You can. It is available. It is available through us and commercially available. So it's something that you can do. But once you start to look into what the payback is, what the benefits are, you may not need to have an ECM motor in that application. However, if you're running something 24/7 and you absolutely need to have something that's controlled by a variable frequency drive and run it at a higher efficiency rating, yes, you can get the ECM. But again, it's not going to be a one-size-fits-all in the HVAC application.
Okay. Yeah, that kind of helps. You know what? You just touched on something that I'm positive everyone's wondering. ECM motors are great, right? To your point, if we get them in the right sweet spot or even go into that larger one potentially. One of the things that I'm thinking about is, well, if I have an ECM motor, do I really need a VFD?
Actually, you do. It's a great question. The ECM motor is actually only powered, or the ECM permanent magnet is only powered by using a VFD. So in the industry, there's a couple of, just to make sure everybody is level set, a VFD, variable frequency drive. There's also something called a VSD, variable speed drive, an inverter, a drive. All of those terms are exactly the same thing. But in the case of an ECM motor, you actually have to use a VFD to power the motor. So it is required.
Interesting. So I can't just get a pump or a fan with an ECM motor without a drive attached to it of some sort so that it can actually run and operate. That's what I'm hearing.
Actually, there is a small exception to that. In some of the smaller units, there actually can be, they can be a little bit larger, but there can be an internal drive. So it's a smart motor that, the VFD is actually integrated versus having a separate VFD on the wall or on the back of the motor. It's actually inside the motor. So there can be both of those, and actually Xylem carries both.
That's pretty interesting. I know that we've got a number of them coming out too. Some of them on the for ESVs and the multi-stage stuff, and I know we've got a couple other products here on the Bell and Gossett side too that I've seen. I've walked a lot of AHR shows and I look and I see some products out there and I'm going, that's an ECM motor. And I could have swore you had to have a VFD with it. So now you basically cleared that up for me. I didn't know that it was a combination of VFD and ECM motor in one. And it kind of makes it a little bit smaller, and it makes it look like a normal pump, for example. So that I'm positive that helps out quite a bit. So, all right, well, when you start talking ECM motors and drives and doing the combination, another term that I keep seeing and stumbling across, and I probably need more clarification from you. But when I look at IE3 versus IE4 or an IE5, and I hear these terms being thrown out, what are the difference between them? I know I mentioned three, and we can start and kind of compare them. But what should I be really looking for? What should I care about?
Yeah. So right now, the NEMA premium specification is actually IE3. So all motors need to be at an IE3 or higher. So the rating actually starts at IE1 and 2, 3. And then what we're looking at is actually jumping into IE4, IE5, which is the highest efficient motor available. In some cases, really what we're seeing worldwide or globally, we're seeing some shifts in the market as far as increased efficiency and requirements. Today, the U.S., the requirement is IE3. However, that doesn't mean that it can't be pushed up to an IE4 and IE5 to make sure that we're being as efficient as possible. And we're making sure that we're offering this technology in anticipation of any changes that could happen in the U.S., really, or to obviously supply our European markets as well.
You touched on something, and I'm thinking about this a little bit. Does this IE rating, I'm obviously in Europe, I'm hearing they're in that IE4, IE5 range, and we're here at that IE3 from a requirement standpoint. Does that mean that an ECM motor, comparing the two for two different manufacturers, doesn't mean that it's an ECM is an ECM? Does that make sense? I'm trying to. Is there a big difference between those two? You said efficiency, but is there something that I should be looking for between those two motors and say, oh, well, that's an that's an ECM, but it's IE3, and this is one that was from Europe and it's IE5, and this is why maybe it costs more or it's more efficient?
There can be different designs and different ways of designing we'll call it the guts of the motor to make it more efficient. So each manufacturer may have a certain line of ECM motors that maybe one line is capping out at an IE4. Maybe they've got a subset that are only IE3, and then they can go up into IE5. So what I'm seeing is that there are different ranges, but what Xylem's focused on is really that upper echelon of that IE4, IE5 rating. So when you're looking at something, if you're just looking at the motor, yes, you can look at that specific efficiency rating. But what it's going to come down to is really that overall pump efficiency. So we're producing the PEI for the new higher efficient units with our very high efficient pumps. So you'll look at the efficiency based on the overall system or the pump and the motor.
So the combinations do really good if obviously putting an ECM motor with the high efficiencies that the DOE is requiring now. I think that makes a lot of sense too.
Want to hear more about how we solve water? Check out In the Field with Gould's Water Technology, a new show in the Solving Water feed. Listen to Xylem experts and industry thought leaders discuss trending water topics, including residential wastewater, agriculture tech, and how Xylem is bringing clean water to Americans in need. Stream episodes of In the Field with Gould's Water Technology wherever you listen to Solving Water.
Maybe you can touch on this one too a little bit, because it does kind of get into the PEI and kind of what it is. Because when we look at PEI, we've heard from a couple other interviews that we've done with Mark Hansel and learned about that on variable load and continuous load and what that looks like. And when they do those calculations, they have VFDs and motors involved. Maybe it would help a little bit on understanding the simplicity of the ECM versus permanent magnet, and then obviously our standard AC induction. So it sounds like there's the upper echelon's the ECM, and then there's a middle ground of permanent magnet. But to be honest, I'm a little confused between those two. And then is it fair to say the induction motors are standard, totally enclosed TFC or ODP? That's right. I mean, that's what we're used to seeing out in the mill. Okay.
Yep. Just the standard motor, AC induction motor is really what the industry has seen as, let's call it, quote unquote, the standard today.
Okay. So what's the major difference between a permanent magnet and then an ECM then? What am I looking at or understanding there?
Sure. Great question. So in the motor world, the terminology can be very similar and people are using the terms interchangeably. So when we're talking about ECM, that's actually a technology. And ECM stands for electronically commutated motor. What does that mean? So what that means is that technology actually has a microprocessor controller inside of it. So it's almost that little tiny brain that I talked about earlier that you're then pairing with a VFD to make it even smarter.
Sometimes this is where I go back to that question of, is an ECM motor an ECM motor between two different manufacturers, or is it really a permanent magnet motor versus ECM? So
right. So So the ECM technology uses a permanent magnet motor. It can also not have a permanent magnet. So what we're looking at, though, is using that technology with a permanent magnet, which basically is what it's doing is it's creating power to one spot on the motor versus another. So if I could be super simplistic, we're talking about one area is being controlled or energized. Let's say the rotor is being energized versus an induction motor is actually having the rotor and the stator energized. So the permanent magnet does it for itself, basically, and you're losing a lot of energy when you have to push movement to both of the rotor and the stator. So this technology doesn't require that. And that's where you're saving a lot of energy, and a lot of wasted energy is, not happening anymore because it's just not needed. It's a higher efficient way that you're designing the motor, and obviously we're getting the benefits of that.
So I'm making sure I understand. So when I look at a permanent magnet motor, an ECM motor is a permanent magnet motor with brains behind it. Is that fair?
Yes.
Okay.
That's
and then a permanent magnet motor could be just a permanent magnet motor, but no microprocessor or brains behind it.
Exactly. You've got it. You hit it right on the head.
All right. So that way, so there really is three different iterations of going from the least efficient to the most efficient, if you will, right? I mean, we've got ODP and the term of TEFC, that totally enclosed, as our standard offering, if you will, for most of the industry, and what you normally is getting. And then you've got permanent magnet motors that are there, but much more efficient than the standard, but no brains behind it. And then you've got the ECM, which is the permanent magnet motor and the brains behind it and a drive to make it the most efficient offering you possibly can, effectively.
Yes, you are correct.
Okay. So let me ask this one, and starting to think about ECM, and obviously, I think everybody likes to get more efficient if they can, and this seems like a pretty simple change or natural change for most pump manufacturers, or especially, and the reason why we're doing it, to add these permanent magnet motor ECM technology to our offering. Does it offer some help in the maintenance aspect of it from the life of a pump or life in general for these motors? Are they considered longer or than the standard?
They absolutely are. So when we're looking at this PM motor versus a standard AC induction motor, the PM motor is running cooler. It is also, and when you heat up a motor, if you think about it, you're actually cutting the lifetime of that motor down as the hotter it gets. So the motor is cooler. The bearings are obviously not running, or they're not running as hot either, so the bearings aren't wearing down. So the amount of maintenance is a lot less. It's drastically reducing maintenance from the induction motor into the PM motor. I talked a little bit about the wasted heat too. So, it's running cooler. You're not wasting that heat that's produced. So you're just pushing out the life of that motor and requiring less touches to the motor because you don't need to. It's running the most efficient that it can be.
That's actually great. And I would tell you what I really like about adding these ECM technology to the pump world is ASHRAE had come up with a number of life expectancies when it comes to pumps, and I found them really interesting. And they really focus on the life expectancy of the pump, and no one really talks about the motor. Usually, a motor is one of those items that, hey, yeah, maybe lightning struck and we had a bad winding, or it grounded out, or something happened and it lasted, call it a year or 2 years. And adding this really, I think, accentuates, if you will, the pump life itself. I mean, we're talking inline pumps, to give you an idea, are right there in the range of 8 to 13 years. Base mount pumps like our 1510 are in that 23, 24-year time frame. So you start thinking of that time frame, and if you had a standard motor, the number of motors that would potentially go bad in 24 years, you could really cut that down if you're an owner, if you start doing this ECM technology and really starting to embrace it. So it's really interesting.
It is. And, you touched on a piece of the lifetime of the motor. So when we're talking about, the pump, that can last 24 years or even longer. I know we've seen pumps in the marketplace that have been out there for 50 plus years. So, but when you're talking about that motor, that's the piece that can be, we'll call it repaired, replaced, and need to be. But what I've learned is that about 97% of the cost of the life of the motor is actually the electrical costs. So by having an ECM PM motor, what you're doing is you're pulling out a lot of the electrical costs because it is more efficient. And your payback on that motor is much quicker, and then the motor life is going to be even longer. So it's kind of a win-win-win where you're saving money electricity-wise, you're saving on the maintenance, and the life of that motor is going to be even longer. So it's all of those things together are really going to get you the best scenario with the, like you said, with the E1510 or some of those base-mounted inline pumps.
Man, that just what popped in my head, and I hear it in the industry, and it's kind of fun. Is that's a true 1 + 1 = 3, right? I mean, from a whole operation. So that's great. I mean, I would encourage everyone to start looking at the ECM technology, especially adding it to everywhere you possibly can. And Jennifer mentioned some of the sweet spots, which is great. I really like that too, to give us some bearings. So Jennifer, I would love to thank you. Thank you so much for coming and having a conversation with me today over this. I've learned an awful lot. I'm positive the listeners have learned an awful lot too. And in the future, please reach out to the local Bell & Gossett rep. Feel free to email me or call me as well, and we can definitely answer these questions. Jennifer's very knowledgeable. She's got a great resume when it comes to being in the industry and understanding this motors, and it showed through today quite a bit too. So thank you so much for coming on the show.
Thank you, Kyle. I appreciate it.
Please subscribe, rate, and review, and follow us. You can download this on Spotify and iTunes.